Let's get started. We have some exciting news today. Nutzipper will be giving us a bit of a demo or a walkthrough of some results. So let's hand it over to Rao for the tech update so we can get to the demo.
All right, let me share my screen and the link for you. So that is the link to today's update, Community Update 141. So yeah, like Greg said, we have some exciting news. I'll cover the releases and where we are with the overall development effort, and then we will go into Nutzipper's demo. So right now, all the mainnet observer nodes and all the testnet nodes are running 09.25.5. Mainnet validators are still running 09.25.4, but will be upgraded to 09.25.5 after we have a few days of testing. This release has the latest version of LMDB Java and has the proxy safe configuration, and Tomislav has also improved some the memory footprint on this. And Tomislav is preparing the 09.26 final release candidate. I heard Juju was saying that some of the Chinese community members have been asking about when would the last finalized state be available. And what is going on for that right now is this release of the final release candidate. And simultaneously, Gurinder is working on creating a couple of souped up last finalized state nodes on the mainnet so that anybody that wants to locally create a version of the node and catch up or test the catch up with the mainnet can use those to do that. And we have some special configuration for those nodes with RAM disk and all that. So that's and a higher memory configuration. So the team is working on that. Should be ready soon. Next week, Tomislav would kind of give a more detailed walkthrough of the how to use the last finalized state facility, and as well some of the other things that he's working on, and I'll speak to them a little bit. In fact, I'll speak to them now. So the focus for the current work, we're basically considering the 09.26 or the last finalized state as complete, other than this deployment activity that I just described. So the focus of the team is on block merge activities, and that's happening in two paths at this point in time. Will is working on identifying and resolving the conflicts in block merge based on the conflict spreadsheet, but that I'm sure many of you have seen quite a few times in the past. So that's what he's working on, and Nutzipper is looking at if, assuming that stream resolves the conflicts, are there any other issues that we need to worry about to enable block merge in the rest of the code base? And that's the piece that he's working on. And we have some nice results there for us to see today that Nutzipper is going to demonstrate. Basically, he's going to demonstrate how the network scales, both as you increase the number of CPUs in a node, as well as you add nodes to the network. And the second part is I think, significant because I know some of the members had asked in the past if that's really possible, that as you increase the nodes in the network, whether you can still get a higher performance because the total amount of work that needs to be done increases. So I think Nutzipper will cover those things there. And what we're doing, the demo we're doing today is preliminary, and of course we'll probably do a few more versions of it as we implement the conflict resolution algorithms and move them onto this side of it to see the total impact as to what the network is like. So that's where we are. Tomislav is working on more improvements to the block store. He's basically on a roll there in terms of both making things a lot easier to manage and a lot more performant. So he may be able to shave a few more seconds off of each, making each block. And the other thing that we're working on really is some bugs the team has discovered in the last few days. And so there was a bug in terms of how the hashing is being done. Sometimes it's done on the whole contents of the block, and sometimes it's done on a partial set. So that's one thing to be resolved, as well as there were a couple of bugs identified in the concurrency implementation. So Tomislav is looking into those. Specifically, one of those Tomislav thinks was behind some of the slashing errors that we saw in the past. So he's working on that also, in addition to preparing the final release version of 0926. Another part of the work stream has been updating the dependencies to the latest. And in particular, this last week, we committed or merged an update to Monix and CATS effect. These are things that provide the concurrency mechanism or concurrency mechanics for the project. So in that sense, it's significant that we were able to get that in. And Tomislav is running some tests with that to see how that improves performance. One of the pieces that we still have to update is the protobufs stuff. The way it is Scala PB and the NetE layer, which provides for the network communications between the nodes. Those two are tied together, and so if we touch one, we have to make a lot more changes elsewhere. So we're looking into that, and that would be also significant when we're done with that piece. The Scala PB being updated to the latest, along with the NetE, would be a significant dependencies update. And the last dependency update, significant one, would be updating to Scala 2.13, though we don't see that as being necessarily very urgent or important, but it would be nice to get to that, because that's where you get to the more recent Scala compiler and all the benefits that come with that. But that again might call for some significant code changes. But first we want to resolve the Scala PB NetE issue, and then we'll see if it makes sense to take on the 213 now or delay it or postpone it for later. But really, the main focus is on getting this block merge pieces completed. The other thing I think I want to say is two things. One is the hackathon marketing is going on. So please use the rchain.coop/hackathon page to market the hackathon to any developer groups that you are familiar with or working with. As of right now, we have about 28 to 30 registrations, but we expect that would accelerate in the next few days and weeks. And again, if you are able to provide us any questions or question banks in Golang or JavaScript or Scala, please ping me, and I'll set you up with the formats to do so. That's what is on the hackathon side. And on tech governance, this last week we met. The primary discussion there has been about sharding configuration. What is the need for it and how is it going to be used? So that conversation is beginning. And when we get to implementing sharding, at some point we will be doing that. There are two parts to it. Obviously, there is the root shard and the child shards within the Rchain network itself. But we also have future plan to demonstrate like Ethereum as a shard of Rchain and maybe something like Hyperledger or something else as a shard of Rchain and be able to demonstrate the interoperability among those. So that will be an ongoing discussion in the tech governance for a period of time. We probably don't have all the answers and perhaps not even all the questions at this time, but we're working through that. That's where we are. And let me see if there's anything else I need to cover. I think that's primarily what I wanted to cover. Are there any questions on any of this before I hand it over to Nutzipper for demo? Or Greg, did you want to amplify anything or change or say anything else?
First of all, thank you so much for the presentation. As always, it's really very, very helpful, and I think everyone in the community appreciates it. Second of all, I did want to say that just to clarify a comment. So the Monix and Cats effects are an abstraction layer. So our in some sense, it's our execution model. It's the row calculus, row lang plus R space execution model that really enables the concurrency from a semantics point of view. And then we have to do a kind of impedance matching between that semantics and the hardware underneath, right? And so we began by abstracting from the hardware using the JVM. And the JVM has a particular concurrency model that's it's very easy to shoot yourself in the foot using the JVM concurrency model. And so we have an abstraction layer above that, which is the Monix and Cats effects. And then we map the Rolang and RSpace execution onto that. So that's one way for people to understand it. We could swap out Monix and Cats and use a different threading library and still get our semantics because our semantics is fundamentally concurrent. And that's important to understand, right? These components are there because they all fit together in a particular way. So our architectural components are what are giving us this scaling characteristics that Nutzipper will demonstrate. Is that clear to folks? Does that make sense? I will take silence as
yeah. Yeah, no, I think that, thank you, Greg. That does actually help explain the relationship among the different layers and components of the machinery that we're dealing with. So thank you.
I think it makes perfect sense.
Oh, good, good. So let's turn it over to Nutzipper then.
Sure. Hi, everyone. So let me share. So basically, the problem that we kind of solved, or at least we know that we are going to solve it. So basically, we solved it, but we don't know if it's correct. So we have to double check and know that we're doing everything correctly. But the issue is the following. You remember in one of previous debriefs, I was talking about merging, and I was showing that we can merge blocks, actually non-conflicting blocks, but we cannot merge them efficiently. So if we, for example, merge, so let me have this as a picture. If we have this block having 9 parents, this means that we will replay all deploys from 8 parents on top of a state hash of one of the parents. And now we are targeting this issue, and this is known as, so this is kind of known as a block merge, which can be split into event log merge and conflict detection. So first we need to detect which blocks are not conflicting, and then we can merge events that are inside blocks. So I was working on these event log merging, and here are results. As you can see, this is the DAG built, well, for I guess 4 hours. And let me go through this stuff. Here is the beefy machine that I have on the Google Cloud. It has 96 CPUs. There are 10 nodes running on this machine. And you can see that it uses all CPUs available, which means that each node is utilizing about 10 CPUs, which perfectly makes sense, because what I'm trying to tell here is that even if each node is proposing a blocks with some user deploy which is sequential, after that these blocks will be added in each node in parallel. So the time to add all these layer for each node to be able to create a new block is about constant, and it's about the same as to replay just one block, which means that if you add, for example, 100 nodes, all of them created 100 blocks, then with more or less reasonable resources, you can merge all these 100 blocks into one tuple space, apply all changes from these blocks into one tuple space hash, and have this hash with all these changes in these blocks as the base for this new block. And then block creation is the same as it was before, so it just executes a deploy, which means this efficient merge and applying event logs is crucial. And you can see that all CPUs are used. This means that node is processing blocks in parallel and creating blocks at the same time. And all this is subject to Casper consensus. So this particular network is running on the synchrony constraint threshold 0.67, which means node have to receive 0.67 stake in blocks to be able to build on top of this set. So in this case, if all nodes are about the same stake, it means that it should receive 6 or 7 blocks to be able to issue a new block. This allows us to tolerate failure of 2/3, and we still can have a finalization in the least restrictive scenario, when we are kind of not allowing a forming of cliques. If we are making Casper more restrictive, that's another question. But now let me just illustrate the speed up. So let me stop this log. As you see, about 117, let me just grab it. And let's see what's the timestamps of blocks created. So first block has been added at 10:45. Well, let's take this one. So, and about 8 hours. So let's keep it simple, about 8 hours to reach this height, which means that we have 10 validators. As you can see in this deck, it's about on each height, each node create a block, then multiply by 100, which means it's about 12,000 block in the deck created. And this is in 8 hours. So 8 hours is minutes, is seconds. Dividing by this, we have about 2 and 5 seconds for a block. 2 to 5 seconds for a block. And if we will look into the logs and see for block creation time, it's about, let me check. What's the easiest way to do this? Okay. Well, it is about 15-20 seconds. You can trust me. So basically, if we only have 2 nodes, which add blocks one on top of another, which means this node, this node, this node, this node, so kind of snake, zip. This means that this node should take about, it should take about 20 minutes from this block trying to create a block, and this node trying to create a block. So block time is kind of about 15-20 seconds. And now we are turning into, as I said, 2 and 3 seconds for block, which means we're about 8 times, have 8 times higher block creation speed, which is basically the 8 times throughput. But the main outcome of this is that if you add more block and run sequential code in these nodes, so you're distributing the payload of the network between these nodes, they all can do things simultaneously, and you can, and nodes can validate these produced blocks simultaneously. And if merging this in efficient way, these will actually be equal to giving up more resources to a single node. So let me stop here and make sure that what I'm saying is making sense. So we have decentralized network, but when we add in more nodes, it's equal. Then it's not. There are still some kind of resources spent on the consensus and all this merging, but still, when we add more blocks, it's equal to having a single node having more horsepower.
It's very clear to me, but I was expecting these results. So I have to see if there are other folks, if other folks get the message.
Does it also mean that it will cost more to run a node if you're running on the cloud, because it will use all the CPU available?
But the actual thing is that, so one thing is that you should maximize your throughput on a single processing power unit. So this is kind of a job of a node creator, how to make node efficient, how to make rolling interpreter efficient, how to make consensus efficient. So all these engineering stuff. But another thing is that so you as a node validator are interested in eating more of your CPU power, because this means that you will earn more fees. So there is a relation. If more CPU power is spent, this means more fees.
Yeah, your node will only be busy if there's a big giant pipeline of blocks being processed. If there's no blocks being processed, your node will sit idle, right? So every time you process a block, you're earning fees, right? And if you have a big network of nodes, all of which are processing blocks, then all of the validators get a cut of that based on their stake. So you want the node to be maxed out in terms of being able to process as many transactions. You want the network to be just chock full of transactions, because then your node's going to be earning you a bunch of rev.
Yeah, so
Okay.
Any other questions?
So theoretically, how far could this scale?
well, there is a there is a spending on the consensus, and there is spending on block merge. So the task is how to make this efficient. But theoretically, it's better to ask Greg.
Theoretically, it's better. That's awesome. No, I mean, the issue is there's going to come a time where adding more, there's a diminishing returns point where adding nodes makes block merge more expensive than the benefits gained. But you could go pretty far out before you hit that. And we've done hardly any optimization, right? We're at the very, very beginning of any optimization. And so with almost no optimization, we're seeing near linear scale out as you add nodes. So, this architecture can be pushed very, very far. And, the point is that we're, in some sense, we're still working with stone knives and bear skins, right? The overhead of the JVM is pretty significant. It would be much, much better to go straight to the hardware, right? And there, it would also be, it would be really nice to go to something that is concurrent from the beginning, as opposed to kind of having concurrency shoehorned into the hardware, which is essentially the architectures of the ARM and the Intel chips. So, as an example, if we were to make a row chip that we ran on FPGA, as opposed to running it on, as opposed to manufacturing a bunch of special purpose chips, we could potentially get 1,000x speed up. Because we're going straight to a hardware that supports the concurrency, and then we can plaster thousands and thousands of nodes over the surface of a single FPGA. So, the upper limit is pretty far out there.
Yeah, the large scale scalability is ultimately the sharding. But I think that, maybe these other consensus structures and such can be made more organic, so that they have decentralized, they're almost shards, so to speak, or they're more like shards.
Yeah, but Jim, the argument I was just making is that, in response to Ian's specific question, if we very, very quickly, the bottleneck is going to be somewhere between the JVM and the existing hardware, right? And this is about the speed within a given shard, right? So we should be able to, with on the order of 100 nodes. So let's check the numbers, right? So he's got a 10 node system. Let's move it out to 100 nodes at near linear scale out. So how many COM events were in a given block?
It's 500 COM events. So you can say that is 200 COM events per second.
200 COM events per second. So now let's take that out by 100. So that'll be 20,000 COM events per second per shard.
Yeah, actually, I did the calculation back of the envelope this morning. I think it was coming, what we're seeing now is coming to about 360 COM events per second, I think is what I came up with.
Right.
Hopefully that's correct, but that's kind of where we are, I think.
So currently what we do is we limit the shards to about 100 nodes. so we, if you again, you multiply that by the existing numbers, then that's somewhere between 20 and 30,000 COM events per second per shard. And that's with no optimization. So we're now seeing the Visa level speeds, right? Which is what we promised. Of course, there's going to be hiccups as we scale out and all of that stuff. But and like for example, we just found a pretty serious concurrency bug that was committed by the previous dev team, and none of those guys were slouches, right? They were all very smart, and it's really hard to get concurrency right, which is why I proposed Rchain in the first place. But the reason I mention it in this context is we expect there to still be growing pains as we scale up. But given the numbers we've got now, the numbers support the trend that I was suggesting, which is 20, 30,000 COM events per second per shard. And you can probably push that, Jim. We can probably, with optimization, gain another 50 to 100% without hiring. Without spending years and years on the optimization efforts. So we can easily get to about 40,000, somewhere in the range of 40,000 COM events per second per shard, which is very respectable. And then you scale out that way. But the point is, you can also scale in a different way within a given shard by changing the mapping from the Rchain execution model down to the hardware, right? That's the place where essentially Rchain is punted. It said, look, it's too expensive, it's too costly to go down that path, right? But now, or from the point of view of risk, right? That's too costly. But now that we've proven out the concurrency and scaling, you can look again at that and you can say, all right, let's de-risk this. Well, one way to de-risk this is not manufacturing a bunch of special purpose chips, but to essentially put those chips onto an FPGA. And now you can tile the surface of a good FPGA with lots and lots of nodes, right? And so now just think about it. The communication path between those nodes is much, much shorter and faster than you'll find inside a rack in a data center. So now let's say you have instead of 10 racks, you've got 10 of these FPGAs, each with 1,000 nodes. Right? So inside that shard, you can scale out very fast. Right, we're talking at least 3 orders of magnitude improvement just by back of envelope. So we're looking at 3 orders of magnitude above the 30,000 COM events per second. Right.
Yeah, but this shard will be centralized, so it's a single chip in one place.
No. The point is you can have a bunch of those FPGAs. So you can have an FPGA in London, an FPGA in Berlin, an FPGA in New York, right?
Yeah, well, if you put a connection, very good connection between these lines, so for sure.
Yeah. So and we're gonna continually fight, the balance between centralization and decentralization. Right. We just need to make sure that the architecture can support the decentralization.
Yeah.
And then where people put the hardware resources, that's going to be a sociological issue, not a technological issue. But anyway, the point I'm trying to make is that from a pure technical point of view, there's no reason we can't get this architecture inside a single shard. So what is that? So 30 million COM events per second is doable if we were to put in on the order of 2 years' work. So that's a significant improvement. And that's because of the architecture. The architecture supports that kind of scaling. Anyway, any other questions about this? About these results?
We are all pretty excited. Yeah.
Exactly. But the one thing I will say is, in addition to the kinds of growing pains that we all anticipate, in all seriousness, we anticipate that there will be bugs inside the code base for quite some time, because we are not able to employ the sorts of behavioral type techniques that we want at the level of Scala or the JVM. When we bootstrap, that will be possible. But even given that, right? Now we're at the phase which I warned about. Right now we have a network architecture which will handle scale, and so without the behavioral types, right? Here's the question you have to ask yourself: if I built an air traffic control system on top of this platform, would I put my child on the plane? Would I put my child on the plane that's being directed by the air traffic control system built on top of this platform? And I'll tell you point blank, and I've been saying this from 2016 onward, without the behavioral types, I would not put my daughter on that plane. So there's still a lot of work that we have to do. For example, the behavioral types, because without those, there'll be bugs all throughout the smart contracts that we just won't catch, because it's too hard to catch them by hand.
And I just want to clarify so behavioral types theory is developed already. It's not OSLF. It's just need to be implemented.
That's correct. There are two prototypes that have been around for the better part of 20 years. So there's the spatial logic model checker, and then there's my Rchain implementation. And both of those have been around for the better part of 20 years.
Thanks.
Didn't Dan do one also?
Dan was looking at combining SLMC with the Rchain stuff. So I think he ported the spatial logic model checker over to OCaml, but you should check with Dan. That's just my understanding. All right, unless there are any other questions, we'll move on and let Daryl give the community in review.
All right, thanks, Greg. Hard to follow that up. That's really exciting to kind of see it, and it's always helpful for us lay people types to just kind of see some kind of visualization. So yeah, thanks, Nutzipper. That was really cool. Okay, so here's the week in review for Thursday the 8th to today the 14th. Last Thursday at the governance committee, they reviewed an application which would facilitate the distribution of dust to all registered Rev addresses for voting. The committee will propose to the Rchain board that RV 2020 be used for voting at the 2020 AGM. Finally, the submission deadline for items of business has been extended to October 14th. It's today. The DApp developer working group last Thursday started work on adding rank voting to RV 2020. Last Friday, the climate coordination call, we discussed the climate crisis in Pakistan and self-sovereign identity. We also discussed Twitter's Blue Sky blockchain initiative and the US Department of Justice cryptocurrency enforcement framework. On Saturday in the RChat call, we talked about ranked voting. Dan did a walkthrough of our RV 2020 Rolang presentation, and we updated and closed some GitHub issues. on Monday at the Casper Stand-Up. This week's Casper Stand-Up covered a weighted version of the annihilation rule for row calculus and showed how to get both timed and probabilistic reduction. And that I just put that up today, so that should be up. If you search on YouTube for Casper Stand-Up, should be there. Our dev member of co-op planning started organizational discussion. Need to get more developers involved. On Tuesday at the Rchain education call, they did RV 2020 rank order debugging, archived old developer website repo, and merged changes from Rchain community /RV 2020 to Rchain GitHub repo. Also yesterday in the communications working group, we discussed how to better promote the hackathon and getting a newsletter out. And the DApp developer working group continued rank order voting development. And today in the members hangout, just before this call, we discussed how our proposed RSAS SPV fits in with helping deal with the concerns brought up in the Netflix documentary, The Social Dilemma. We also discussed board nominees, and Jim showed Dan's work on rank voting, and conversation shifted to potential sovereign.org, connect.me, and Blockspace's partnerships. And I would just like to note that yesterday I posted Steve Henley's excellent video walkthrough of the voting process. It's up there at blog.rchain.coop, and I highly recommend checking it out before the AGM so that you're clear about the voting process for this year. Of course, this is very exciting because we're demonstrating actually using our mainnet for voting this year. So yay for everyone. Special thanks to Dan. It's really exciting, and I can't wait to vote on mainnet. And I guess that's everything for now.
Awesome. Any questions for Daryl? Okie dokie. So the board had a special meeting, and the board voted and resolved to create an internship program. So the idea is to have some number of board interns who become familiar with how the board operates. So they kind of learn the bylaws, they learn the procedural and logistical aspects of being a board member. So it's a great way for someone who's contemplating becoming a board member in, at the next election, for them to learn the ropes. And it's something you can put on a resume, you can put in a pitch to the community, all of those things. So definitely please consider the program if you have any interest in the nature and structure of the program. The board and I guess the governance committee will be contemplating sort of the details of how that how it is put into place. So do that, and if you have an interest in becoming an intern, a board intern, please don't hesitate to reach out to us. You can contact me or Lilia or any of the board members. Any questions about that? All right. Any questions, burning comments, worries, concerns, issues, enlightenment that the community wants to put out for consideration?
Are there any board candidates online that could answer some questions?
Greg, there was a question from AJ, and he's asking, what kind of applications are suggested in the hackathon?
Right. So we have several. There's sort of near-term fruit, which is advancing some of the backlog on RChat, and we have a few things that are coming from the SPV. So there's lots of work that can be done in demonstrating the decentralized advertisement platform. And then, of course, if a creative group comes with their own application, we're quite interested in that. I should also mention that we've begun engaging with a group who won a grant for distributed digital identity on the blockchain, and so we're going to help them formulate the requirements for their grant deliverables. And so the extent to which that turns into a prototype specification, that's also fair game for the hackathon. Does that make sense? HJ, did that help?
Well, I was expecting a bit more, but yeah, it makes sense. Yeah.
Cool. I mean, if you have, I mean, there's only going to be so many teams that we can keep track of. But if you have specific application areas, feel free to suggest them, propose them.
Yeah, and also keep in mind that basically the teams can propose their own problem statements that they want to work on. So while we have some backlog and things that we want to propose or provide as problem statements for people to work on, the hackathon is not restricted to that. People can, bring their own problem statements and work on those. So.
Yep. Okay. Any other questions, comments, concerns from the community? Awesome. Thank you so much. And looking forward to chatting with you on Friday for those who join the closed door session. Have a good week, folks. Stay safe.